Hello and welcome again to Simplified RSA. We are the guys who makes it looks easy. And today we have this interesting question. Let's go straight to it. So here is our question for today. Let me just make space for it. We'll be doing question 5, right? For someone who understands a bit of what's going on there, you can say that the question relates to energy. So meaning we'll be talking about energy mostly on the question, right? And deeply in my understanding, I believe everyone understands the concept of energy. I would say so because we use the word energy in our daily conversations, and someone would feel like, I don't have enough energy. Let me go get an energy drink somewhere. And then you go buy yourself, what's that? More flames or something. Okay. Yeah. And then you consume the energy and then it's converted into some energy and then it gives you energy to prepare for your exams, something like that. So like, I'm just saying we do understand the concept of energy somehow. The problem only starts when we relate it to the academic world, which is now questions like this. And now, as much as we might not understand what is this energy that we're talking about, but there is that clue or that light that says energy is something that has to do with some work done, right? Depending on how you look at it though. But now let's go to this question. But before I start also, I just want you to know that, okay, Sharp, the whole concept of energy is just that we have a whole lot of different types of energies. And we're going to talk about the different types of energies as we go, or rather as we diverse deep into physics more and more and more and more. So, but then for this one here, when I scrutinize through the question, I see two types of energies that we're going to talk about today, which is kinetic energy and potential energy. Two types of energies, but then we're going to answer those questions as we go, and everything is going to unveil itself like that. So the question reads, a skateboarder starting from the top of a ramp, which is 4.5 meters above the ground, skates down the ramp as shown in the diagram below. The mass of the skateboarder and his board is 65 kg, and we can ignore the effects of friction. As we see on the diagram there, now 5.1, we are required to define the term gravitational potential energy in words. Gravitational potential energy in words. Normally, questions like this, they don't worry me because it's like, it's theory. No, I mean, if you are preparing for an exam, you're going to study your definitions and stuff if you have to do what you got to do, But how do we answer this one? You can just say things along the lines of, so don't worry about the definition. I'll put the definition as it is here. So you can just say things like gravitational potential energy is the potential energy associated with gravitational force. So it's the energy of height associated with the gravitational force. Now, just for the fun of it, put kinetic energy, which is the opposite. Now you can see now it's associated with motion and movement because it has velocity attached to it. So we have potential energy, which in summary, if you want to simplify it at the back of your head, you can say potential energy is the energy of height, and kinetic energy is the energy that is associated with motion because of the velocity that is involved and the mass, stuff like that. And work is done for energy to be conserved. We're getting somewhere, right? But all in all, we're just talking about the whole energy and everything. And now on our question, we've defined 5.1, and then 5.2 it becomes the interesting question. They say calculate the gravitational potential energy of the skater just before he skates down the ramp. They want us to calculate the gravitational potential energy. Now, after defining this gravitational potential energy, which we then said is the potential energy that is associated to gravity, now we have to calculate that energy. And then this is how we're gonna do the things. I've tried to have us have our structure here. So it's similar to what we have there. There is Mr. Man. It's just that, yeah, man, 4.5 meters. And then we have Y there, point Y, which is 6 meters above the ground. And then we have point X. And now 5.2, we are required to calculate the gravitational potential energy of the skater just before he starts skating down the ramp there. So we have to calculate the potential energy here. So that's when we'll say 5.2 EP So we can calculate it like this. I would say 5.2 EP is equals to mgh. So that's the formula for potential energy just here before he skates. So m being the mass of the skater and the mass of the skater and the skateboard combined, which is 65 kg. G being the gravitational force, we all know the gravitational force, we assume it to be constant, which is 9.8. And then we have the height of the person where he was at that point. That was 4.5 meters above. Therefore, we have the situation whereby it's 65 times 9.8 times 4.5. And then our answer will be 2,866.5 joules. So the SI unit for energy, we measure it in joules. So it's 2.8665, like that. So that is for 5.2. And then 5.3, now 5.3, we have to state the principle of conservation of mechanical energy in words. Well, there's a lot involved now, but let's step back again to the whole concept of energy. Again, you ask yourself, how does now DJ Spoo get energy and get it stored inside a can to sell it for me for 10 rands because now I need to refresh or rather re-energize myself. So when I drink that content and then I feel energized, the energy now is converted into some sort of energy that now boosts my body to do what I have to do. Like, how does it work? How does it move from here to here? So then that brings us to some way to relate to the conversation of mechanical energy. But otherwise, the principle is also known as the law of thermodynamics. Energy cannot be destroyed nor created, but it can be converted from one form to another. So not in any day will you ever destroy energy, or not in any day will you ever destroy new energy from something. So energy cannot be destroyed nor created, but it is transformed from one form to another. I think now this goes big into the whole science explanation now, because we have a whole lot of different types of religious that believes in different things. So now, when you hear energy cannot be destroyed nor created, that should like bring a whole lot of questions. It cannot be destroyed nor created. The very same energy is just converted into one form of energy to another form of energy over and over and over and over and over and over. That should think like even probably when you die, all that energy of the soul that comes out, it's converted. Hey, let me not go there. Let me stick to this. But yeah, so to state the principle, for you to get full marks, you can just say something like this. So you can just say the law of conservation of energy states that energy can neither be created nor destroyed. It can only be converted from one form of energy to another. This means that the system always has the same amount of energy. So there's always going to be the same amount of energy lingering around. So it's just converted from one form to another, either from potential energy to kinetic energy, from kinetic energy maybe to electrical energy, from electrical energy maybe to heat energy, from heat energy maybe to, I don't know, man, like it can never be destroyed nor created, but it's only converted from one form of energy to another. Let that sink in. Should you understand this concept, I swear to God, a whole lot of things that we're going to talk about after, whenever we state energy, you will know that, okay, sharp, I'm looking at this type that I may actually think of, but just know we have different types of energies like that. So that's how you define the law of the the conversation of mechanical energy. Now, 5.4, we have to use the principle stated in question 5.3 to calculate the magnitude of the velocity of the skateboarder when he reaches the ground at point X. So we have to calculate the velocity using the conversation of mechanical energy. We must calculate the velocity of the skateboarder as it reaches the point X. I feel like I should minimize let me, now that I've reduced my scale, we can say that the conversation of mechanical energy state that the total energy at the top, should be equal to the total energy at the bottom. What is this total energy? The total energy is the potential energy together with the kinetic energy. Also, here, the total energy is going to be the potential energy together with the kinetic energy. So this is what the conversation of mechanical energy states. It states the total energy at the top, which is potential energy plus kinetic energy, should be equals to the potential energy plus the kinetic energy. Meaning now we can approach our 5.4. We can approach 5.4 by saying the potential energy at top is equals to, the total energy at the top is equals to the total energy at the bottom, which is point X, according to the question, because we have to calculate from where the skater was until he reaches point X. They want to know the velocity. We have to calculate the velocity at point X. Now, we know that potential energy is mgh and kinetic energy is half the mass multiplied by the square of the velocity. So we know that we have this information right now. We have this information. Conversion of energy states that the total energy at the top is equal to the total energy at the bottom, and we know that potential energy is mgh and kinetic energy is half mv squared. But look at this. At the top here, what was our potential energy here? We already calculated our potential energy, which was 2866 plus 2866.5 plus, what was our kinetic energy here? Because kinetic energy has something to do with velocity. At this point at the top, there was no movement because the guy hadn't started skating. So the kinetic energy is going to be, if you calculate it from the top here, the kinetic energy from the top is going to be half the mass 65 multiplied by, because the guy is at rest, is going to be 0 squared. So anything multiplied by 0 is going to be 0 joules. So meaning at the top there, the total energy is EP plus the kinetic energy, which is 0. So I'm going to say at the top is EP plus 0. Now, let me just remove this so I can explain other stuff. Now, I get to the bottom. So here, I have this situation. Potential energy is mgh, mass multiplied by gravity multiplied by the height. On point X, the height is 0 because this thing now is on the ground. The height is 0, meaning my potential energy now becomes 0 plus my kinetic energy. My kinetic energy is going to be half the mass of 65 v squared, but I don't know the velocity, which is what I can calculate right now, which is what they want me to calculate on this question. So then go and say I can go say, oh, because now the V squared is what I have to calculate. I can now finish the whole stuff now. So this is how I put it on paper. 5.4, because I have to calculate the velocity using the principle I've stated in 5.3. Now, as I've stated with the principle, the way it's the total energy at the top, where the guy before he started skated should be the same as the total energy at the bottom as he slides down. But now we broke it down. So this is the total energy at the top. The total energy of the top, we said, is EP plus EK from the top should be equals to the EP plus EK at the bottom as he lands down. But somehow, like I said, here the top energy already calculated it from 5.2. So we found our potential energy to be 2,866.5 plus, as we said, the kinetic energy there will be 0 because the guy hadn't started movement. So there's no velocity for there's no velocity. The velocity is 0 for us to calculate the kinetic energy, hence it's 0. Therefore, this is going to be equals to the potential energy now at point X is then becomes 0. It's 0 now because there's no height there. But the kinetic energy is, as we stated, is 1 over 2 65 over 2 V squared. I think you can get how I simplified this. So because it's 1 over 2, I can just multiply it by that. So let me just say 65 over 2 for now. So we have this situation now whereby our only unknown variable is V squared. So we can calculate our V there. So therefore, this is going to be 65 V squared is equals to, I might as well just cross multiply from here to there. So if I cross multiply, I will have 2866.5 times 2. Therefore, it becomes 5733. I divide by 65. I divide by 65. This cancels that. Therefore, V squared is equals to square root of 5733.65 because I have to get V like that. I think you see where this is going. Therefore, V, which is our velocity now. So at point X, the velocity is 9.39. 9.39 meters per second. So at that point, when the guy skates, like by the time you got to point to X, the velocity, the V was 9.39 meters per second, just at that point there. So that's how we get the velocity for 5.4. And then here's another interesting one. 5.5, will the skater 5.5, will the skater be able to reach point Y if he were to remain on his skateboard? Write yes or no and support the answer with relevant calculation, right? So as the skater skates across point X and then he climbs up, approaching point Y, will he reach point Y, yes or no? We then have to do the calculations, right? Let's do the things. To answer 5.5, again, using the law of conservation of energy from one point to another, we know that now let me change my scenarios, right? Let me change my scenarios because now I'm looking at from here, I'm looking at this segment now. So now here on this segment, I know that at point, the total energy at the bottom here, the total energy at the bottom here should be equal to the total energy at the top. The total energy at the bottom here should be equal to the total energy at the top. I want to know if with this velocity that the guy left point X with to approach point Y, is the velocity enough to give us the height that is gonna be equivalent to the height that is point Y? That's how I will know if the guy will reach the point or not. Look at it like this. The total energy here on the bottom, my potential energy is 0, my kinetic energy, now I know what my kinetic energy is at the top. My potential energy here is 0 because there's no height at point X. And my kinetic energy is half the mass, 65, times the velocity, because now I know the velocity, 9.39 meters. Or even if I don't write it for now, I can just say 9.39 like that. So this is my total energy at the bottom, 0 plus that. Now, I want to know, based on this velocity, what would be the total energy for the top in terms of the height? So, because eventually this person has to stop, the kinetic energy is going to be 0 there. But like, okay, let me first say EP plus EK, because it's the total energy concept according to the conservation of energy, right? And our EP, because as the person goes back up, eventually he reaches to stop, but we just want to know, like, as he stop, does he reach this height or not? So the potential energy, I would say, is M, the mass of 65, times the gravity, 9.8, times the height, which I want to question what this height is going to be. And then plus, I know the kinetic energy, like I say, is going to be 0, like that. So, meaning we can have our proper equation where then we would say, or conservation of energy, say the energy at the top is equals to the energy at the top, the total energy at the top. The total energy at the top is equals to the total energy at the bottom. This is the conversion of energy. So now we have this situation at the top. We have 65, 9.8 H plus 0. This should be equals to, in the bottom we have 0 plus 1 over 2, 65, 9.39. And as you can see here, we only have the H that is unknown. So if we can calculate this H and we found this H to be something more than 6 meters, then we can say, yeah, the guy did reach point Y. If the value of the H is less than 6 meters, then we'll say, no, the guy didn't reach the point. So let's simplify that. Therefore, this will give us, if I simplify this, I will have 2,865 joules 66. And it only makes sense because it should be energy at the top should be equals to energy at the bottom, because it keeps on being converted from one form to another. And here we're going to have 637H, right? But we're looking for the value of H. If I divide by 637 here, I divide by 637 here, therefore H is going to be, so the height is 4.5 meters. So the height is exactly the same as the way the guy went from when he left. From when he left 4.5, he went and then he went 4.5 again and stopped. It didn't reach 6 meters. So the answer is no. The guy didn't reach 6 meters because the height, according to the velocity from when he was passing point X, the height is only 4.5 meters, which is exactly the same as the height which he was previously before he started to skate. So if the distance was 6 meters, or if the distance was 6 or more than that, then you would have reached the thingy. So now I believe whenever you go buy that energy drink, you'll understand what energy is about. By the way, when you drink that, you are not drinking potential energy or kinetic energy from the energy drink. We're talking about some energy that come in a form of glucose, like sugar and stuff. So it then gets converted. So now we're talking about biological studies, where now we talk about different types of energy as well. But like I say, there's a whole lot different list. I mean, there's a whole lot different types of energies. So I think for this one, we've answered all the questions. I'm Mr. My Money. This is Simplified RSA. We are the guys who makes it looks easy. Please subscribe to our YouTube channel. Follow us on all our social media platforms, and also you can access our learning channel through Spotify. And yeah, follow us on TikTok as well, because we go live every now and then. Until next time.